we are back. Oops, there we go. Cool. So, alright. So we today are talking about working with multiple data frames and how to kind of smush different pieces together. Because usually in our work, unless you have fully designed and had 100% control over this data and entered all of it yourself, it is very likely that you will have to combine data sets. And yeah, I'm in my undefined meal time. So yeah, let's start talking about how to work with multiple data frames. So we have multiple data frames and we want to bring them together. So let's start with an example. Looking at women in science. Here are 10 women in science from a data set that we will be working with very soon that have changed the world. Cool? Cool. Some of these you may be familiar with, others maybe not. So if you get bored and want more things to do, feel free to check them out. So here is our... Yeah, oh good, we got all 10 in here. It's a little tight at the bottom. But Jennifer Doudna? My pronunciation is awful. I'll make it on this. So this is the professions data set. We've imported it. You can look at the slide markdown code to actually see it. You're welcome to download this data too. It's all in there. But yeah, so we've got a data frame, Tibble technically, with 2 variables, name and profession. We've also got another Tibble. This one has 8 in it, where we have the birth and death year for many, for 8 of our STEM ladies. The reason I know it's 8 and not just being cut off is the Tibble here, it says 8 by 3. So I know that it's got 8 rows and 3 columns. It's always rows, then columns. And lastly, we got work. So here we've got a table with 9 rows and 2 columns with name and a character string with a very narrow description of what they're known for. All right, here's what we want our data to look like. We want a data frame, Tibble, with 10 rows and 5 variables. We want name, profession, birth year, death year, and what they're known for, all in one data frame Tibble. How do we do it? You may be asking yourself. Or you may have already had this thought, Mace's probably going to tell us, because otherwise, why is this a video? Very astute. Very astute. So, just to remind you, we have 3 data sets here. One named professions, which has 10 rows. One named dates, which has 8 rows. And one named works, which has 9 rows. Anyone seeing a slight problem? We will soon. All right. So that is our stage. Now, in order to do that, we have to talk about how you join data frames together. There are lots of ways to do it. All right. So here are all of the ways to do it within Tidyverse. You can also cbind and there are other ways, but outside of Tidyverse. But we're starting with Tidyverse. All right. So left join allows all rows from X and only those that match up from Y to be joined into your new data frame. Right join is the inverse. All the rows from Y and anything that matches from X. Full join is all rows from both X and Y. Semi-join is where all the rows where there are matching values in Y, keeping just the columns in X. Inner join is all the rows from X where there are matching values in Y, and it returns a combination of all multiple matches in the case of multiple matches. Anti-join returns all rows from X where there are not Ys. It never duplicates rows. Those are just some. There are lots of these. I tend to have to look them up each time, which is actually why this slide lives here, so I don't have to do it during the lecture. All right, so just for the next few slides, just so an easier one, we're going to have two tibbles. The X tibble has IDs 1, 2, 3, and a character string with X1, X2, X3. And the Y tibble is going to have IDs 1, 2, 4, and then we're going to have a Y value of Y1, Y2, and Y4. So that's where we're going, just so we can have small stuff to work with together. All right, here's left join. Visualized. So we can see that the end result here is that when we join them together, 1 and 2 match up, and we keep 3 and drop 4. So we are starting with the X, with the left. And so the end result is that we have a tibble that's 3 by 3 with our third value missing for Y. All right, so let's do it for our STEM ladies data. We're going to start with professions and pipe that into left join. So here we have 10 rows with 4 columns, which is probably a solid way to do it because we didn't have birth and death data for Marie or Ada. We just didn't in this data set. So we join them in. Now we have a 10 by 4. But what about right merge? It's the flip where you keep everything in right and then merge in what you can from the left. As you can see, animated. Feel free to slow this down. I have it captured at 60 frames per second, so it should work on the screen capture. We will see. All right, so let's do, now if we right join with dates, we get a tibble with 8 rows and 4 columns. Because we just didn't have those 2 with dates. We didn't have Ada or Marie in our data set. So we started with, so kind of you can think about it, like what you are joining into. So you join from the right for right join and for left join from the left. Okay, full join gives us both. So we get to keep both all the variables in X and all the variables in Y, and we plop in missing data. Cool. That's full join. And now in this case, full join with we're jumping to full join with works. So in dates we only had 8, remember? And in works we had 6. So here we've joined them together to combine our data sets, essentially, and matching them up to create a new data frame with 10 rows and 4 variables. Inner join. Inner join only keeps the data that have both values in X and Y. So we've dropped 3 and 4 to get our tibble. Now this is helpful if you're really interested in only complete cases, or or other reasons that you will have envisioned on your own. As someone who hoards data, I like to keep everything all the time. But inner join can be useful from a data reduction technique. So here, or if you're particularly interested in one data frame. So here we've inner joined dates and works, and we get a table with 7 rows and 4 columns, because those were the only 7 that matched both. Semi-join is pretty equivalent to inner join in this case. Yeah. They do slightly different things. But the end result here is the same. Oh no, I lied. Oh, what they're doing is we're semi-joining, but only keeping the variables that are in X. And so the end result is we only have the database values for 1 and 2, because 3 and 4 were incomplete. So when we semi-join, we effectively are subsetting our data, so it's only the data values that are present in works, but we don't actually keep anything from works. Fun facts. Anti-join is kind of the inverse, so where we see what stuff in X is not in Y, and we keep that stuff. So we can see here that anti-join, the only person not in works but is in dates is Rosalind. Now we can put these all together to create our final data set. So here we've piped professions into left join, and then piped that into works to create this 10 by 5 to get pretty much all the data. So that is it for joining. Thanks for joining us on this journey. I'll see you in a bit.